Okay, hey, I want to talk a little bit about 10.3, 10.4 polar coordinates. And to get you started with polar coordinates, let's just think about, let's go back to thinking about the basic Cartesian system, which is an XY plane. You have a x-axis, you have a y-axis. Any point can be located with two numbers. And the first number we label as x, and the second number we label as y, just out of convention, the alphabetical logic of x being before y. So like this point, I'm just making stuff up here, just to be the same point. Let's just say that I've got 3, 4. That means I've gone 3 units to the right, 4 units up, and that locates this point out here. So another way to locate that point is by saying how far is it away from the origin and what angle have we turned through. So this is our theta notation, and this is what we call the polar coordinate system. Now, because the 3, 4 can be connected to a right triangle, there's some basic trigonometry that we can do to figure out the relationship between x and y and r and theta. So first of all, we got the Pythagorean relationship, x squared plus y squared must equal r squared. And then we also have sine theta equals y over r, and cosine theta equals x over r. And generally we'll manipulate these to get x solved for in terms of theta and r, and y solved for in theta and r. So this equation we rewrite as y equals r sine theta, and this one we rewrite to be r equals x. That's not right. X equals r cosine theta. That's what you get for trying to do algebra in your head. So let's, before we go on and just do a couple examples, let's actually look at a real polar graph. You can do this in Desmos. They have a way to switch. I'll show you between Cartesian and polar. So here, the grid, this is the polar system. This is the Cartesian system. I've already switched over. So if I plot a point, 3 and 0, that takes me out to that point, but that's a little confusing because I don't know whether that's in the Cartesian system or in the polar system. So I'm going to now say 3 comma pi fourths. Let's see where that puts me. So yes, I think this is still reading my points as XY points, because it put the blue one exactly above the red one. That's not right. So let me see. In radian mode. Hold on a second. So they don't allow you to put in polar numbers here. You can only plot them as Cartesian numbers. So that's why you see r cosine theta, r sine theta. I'm using a instead of theta just because it's easier to type. They give you a little slider here. So if I wanted to plot the point, this is the polar coordinate. I think I had written down Theta on top of here. I think I wanted to do 3 pi fourths. So the R slider is easy enough because I can just slide that out to 3. This one I've got to slide down to whatever pi divided by 4 is, which would be 0.7 something. So yeah, that kind of puts me in the right-ish kind of spot. 3, and I'm going to do, well, I can actually just write this out, pi divided by 4. There we go. So there's that point, 3 pi fourths. So you can see that the way the polar graph works, I've got concentric circles starting at 0, 0, and then I go out. This is steps of 1. So this is on my third step. So that's 3 is the first number, and pi fourths, my angle, is the second number. And that's the angle that I've turned through. And you can see this is not labeled here, but this line is the pi fourths line because it's pi fourths of a turn off of our reference line, which is always the positive x-axis. So this point is 3 comma pi fourths. So the first thing that we'll do is we'll just practice going back and forth between Cartesian and polar coordinate systems. And so let's go back to paper here and let's do some practice problems. So let's say the problem is something like convert 4 to polar coordinates. So to do the polar coordinate, I need to find out what is r and what's theta. So a good starting point is to find r, and we can just use this equation. Of course, it's just coming from the Pythagorean theorem, which is that we've got 3 squared, 9 plus 4 squared, 16, and we want to do the square root of that. And I picked some nice values because, of course, that value is 5. Okay, now I need to find theta. So theta can be derived from either one of these equations or one of these equations. Basically, I know that y is 4. I know that r is 5. So 4 equals 5 sine theta. So 4/5 equals sine theta. And so now I just need to figure out what theta is, and I'm coming up with an approximation. I would just use the inverse sine to come up with an approximation of what it is. Calculator. Shoot. Hold on. Okay, so I'm going to go to the nearest hundredth, and of course I'm in radian mode because everything here should be in radian mode. 0.93 radians is approximately my angle. I had to round it. So then that point is 5 comma 0.93. And let's just quickly go back to Desmos for a second. So share screen, Desmos, boom. So let's move our slider up to 5. And let's move our angle up to 0.93. And let's see where that point puts us. Gotta zoom out a little bit. Okay. So if I go back to the Cartesian system, I should see that I'm about at 3, 4. And I don't know if there's a good way to do that. Let me just see if I switch back. Yep, there it is. Very close to 3, 4. Right. It's a little bit, looks like a little bit off to the left, but there's 3, there's 4. Right. That's the Cartesian point, and 5, 0.93 is the polar point. Polar Cartesian. Okay, let's go back the other direction. So if I'm given a polar coordinate, -2 comma 3 pi fourths Cartesian. Let's see what happens. So what do we know? We know x equals r cosine theta, and we know y equals r sine theta. So let's just plug it in. -2 cosine 3 pi fourths and -2 sine 3 pi fourths. Okay, so let's see, cosine 3 pi fourths, that's the square root of 2 over 2, no, negative square root of 2 over 2. So this is -2 times negative square root of 2 over 2. And this is -2 times positive square root of 2 over 2. Okay, so we got a lot of cancellation happening here. We got negative times a negative. We also have the 2's. So this should just be the square root of 2. And this one should be the negative square root of 2. Okay. So then my Cartesian point should be square root of 2, negative square root of 2. Let's check it out. So back to Desmos. Let's share. So we're going to put here 3 pi fourths. And we're going to put this one as -2. Okay. And here's our Cartesian point. Let's switch over to polar real quick. So I want you to think about what that -2 signifies. So first of all, the 3 pi fourths is turning through this angle here. So we're facing this way. That's the way that we should be going. But because r is -2, we actually go out the backside and we come this way. So this is our polar point, -2, 3 pi fourths. Is it the same as what we calculated? Well, we said square root of 2, positive square root of 2, negative square root of 2, right? So looks like it's about right. If we take this off, let's just plot the point, see if it's on top. How about that? It's a little hard to tell. Clear this off. Okay, so here we go. Square root of 2, comma, -2. Okay. Same point. A little bit off there. Again, using an approximation, but I'm pretty happy with where that puts us. It's the same point. So you can use Desmos. It's a little challenging to kind of use this system because it really is designed for a Cartesian system, not a polar system. But those are the first types of questions that you'll be asked. It's just going single points in both systems and converting it to the other system. So next video, we'll talk a little bit about taking that for an equation and doing that same conversion process. So taking something that's written in Cartesian systems, what we're familiar with, the y equals x format, and we'll convert it into polar and see what that looks like.